Alright, so today our Explore More topic is exploring more with literal equations. Okay, so in class you've been doing problems where maybe it was like ax plus b equals c, and then your directions were to solve for x. And so you subtracted b from both sides, and that gave you ax equals c minus b, and then you were trying to get x by itself. So to get rid of this a, you would divide both sides by a, and so your answer would be something like c minus b all over a. Okay? So those are literal equations. You guys have been doing those in class. So how can we explore some more with this? So something we didn't cover in class much was literal equations when there was a squared term or a squared root term. Okay, so let's review something we talked about earlier in the year. If you're trying to solve an equation that has a squared term in it, like x squared equals 4, so we would do the inverse operation of squaring this term, and the inverse operation of squaring is taking the square root. And so we would take the square root of 4, and then we talked about anytime you introduce a square root into an equation, then we need to have the positive and the negative version of that answer. And so our answer would be positive 2 and also negative 2. And that allows for when we plug these answers back in, if we have 2 squared, that would be 4. Or if we have negative 2 squared, negative 2 times negative 2 is also 4. Okay? So the inverse of squaring is taking the square root. So how does that have to do with our literal equations? So let's say instead of solving for a value like 4, what if we have a literal equation like x squared equals a? And we're still trying to solve for x. So we would still do the inverse operation, so take the square root. And when we do that, we have to introduce the plus or minus. And so our solution would just be x is equal to the square root of a or the negative square root of a. And we can't find that value, and so we would just leave our solution like that. Okay? So how could this get more complicated? Okay, so here's 2 examples that we can take a look at. So the first one says ax squared equals b. So we're trying to solve for x. So the first thing we would do to get x by itself is we would divide by a. So this is very similar to our strategies in class. So this would give us x squared equals b over a. And then to get x by itself, we would do the inverse operation, which would be taking the square root. And so we would get x is equal to plus or minus the square root of b over a. Okay? Or in this one over on the right, we would start by adding a to both sides. So this would be x squared equals b plus a. And then do the inverse of squaring, which is square root. And so we would end up with plus or minus the square root of b plus a. And remember, this is really 2 separate answers, right? It's the positive square root of b plus a, but also the negative square root of b plus a. Okay, so now if we look at these examples here, these examples are starting with the square root already in the equation. So we're trying to solve for x. So if I start with the square root of x equals a, and I'm trying to solve for x, I have to do the inverse of taking the square root. So the inverse of a square root is squaring both sides. Okay, so I'm going to square both sides of this function. So when I take the square root of x and I square it, that would just be x. And then I would be left with just a squared. And then that's it. X is equal to a squared. It's not plus or minus or anything like that. We squared both sides and we got x by itself. So on the second example, same kind of idea, but before I can square anything, I'm going to get rid of this a, the coefficient that's out in front, by dividing both sides by a. So this would be the square root of x equals b over a. And now I can square both sides to get rid of my square root. So this would be b over a squared. Okay, so then the last piece of this puzzle is, what if instead of having an x squared, what if we have like an x to the 3rd power? Okay, so just as a recap, if you have something like 2 to the 3rd power, then that means we're taking the number 2 and we're multiplying it by itself 3 times. Oops. Okay, so if we have an x to the 3rd power, that would really be x times x 3 times, right? So how do we undo taking an x or a variable and raising it to the third power? So the inverse operation of cubing a number is to take the cube root. So if I ask you what the cube root of 8, what is that value? We're asking what number times itself 3 times equals 8. And so that answer is 2. 2 times 2 times 2 is equal to 8. And so the cube root of 8 is equal to 2. Okay? So taking the cube root is the inverse operation of cubing a number. Alright, so if we take a look at some literal equations that have cube roots in them, how are we going to attack this? So first thing we would do is, just like the other problems, we're going to get rid of this a that's out in front. We would do that by dividing. So this would be b over a. And then the inverse operation of cubing a number is to take the cube root. And so I would take the cube root of both sides. So the cube root of x cubed is just x. And then I would be left with the cube root of b over a. Okay? Now, when we take the cube root of a value, we do not do the plus or minus. Okay? And that's going back to our example over here. If you take the cube root of 8, the only answer there that makes sense is 2. Because if you had negative 2 times negative 2 times negative 2, that answer would be negative 8. And so the plus or minus does not apply with cube root functions. Okay, so then our last one over here, we would solve this like normal. I have a cube root already. So I would start by adding a to both sides. So this would be b plus a. And then to get rid of a cube root, the inverse operation is cubing that. And so I would raise both sides to the third power. So the left side would just be x, and then the right side would be b plus a to the third power. And we would just leave it like that. We don't need to FOIL or distribute that. Okay, so hopefully that makes a little bit of sense with taking the square root and cube root. Go ahead and practice those extra explore more problems, and let your teacher know if you need some help.